Let's solve this linear system using the Cramer's rule. The Cramer's rule allows us to solve for the values of the variable here, specifically x, y, and z. Using these ratios, we have the determinant of a sub 1 over the determinant of a. Y is for the determinant of a sub 2 over the determinant of a. And z is the determinant of a sub 3 over the determinant of a. This means we need to write or create a matrix A out from this given linear system, excluding the constants. And a sub 1, a sub 2, and a sub 3 will be discussed a little bit later. So let's start with A. Okay. A is a matrix, 3 by 3 matrix containing the coefficients of the variables. We have 4, 5, 0. We have 11, 1, and 2. We also have 1, 5, and another 2. This is your A. Now we can solve for the determinant of this, okay, using the method that we on the flow of from upper left to right, that's positive, or add all results, and then from upper right to left, that's negative. In short, we're going to multiply this here and here as well. Those are all positives, and these are all, addition, and here would be all subtraction. But let's start with this. We'll have 4 times 1 times 2. Our first result is 8. To be followed with 5 times 2 times 1. That's plus 10. Next, you have 0 times 11 times 5. You will have plus 0. Minus the next movement. 0 times 1 times 1. Expect to have 0. Next, 5 times 11 times 2. That's 55 times 2. So you will get 110. Yeah, 110. Next, you will have 4 times 5 times 2. That's 20 times 2. You will have plus 40. So you have here 18 minus 150. So your determinant of A is equal to negative 132. So that is the value you're going to place on all the denominators here to solve for your x, y, and z. How about A sub 1? A sub 1 is a matrix where we interchange, or we all entries on the first row corresponding to your x, the coefficients of your x, and change it to all the constants here. So instead of 4, 11, and 1, your first column would be 2, 3, and 1. The rest of the columns would be the same. 5, 1, that's 5. 5, 1, 5, and 0, 2, 2. So we can now solve for the determinant of A sub 1, which follows this pattern. 2 times 1 times 2, you will have 4. Next, 5 times 2 times 1, you will have plus 10. Then 0 times 3 times 5, that's plus 0. Minus the next flow cycle, 0 times 1 times 1, 0. Next, 3 times 5 times 2, that's 15 times 2 is 30. Next, you have 2 times 5 times 2, you will have 10 plus 2 times 2 rather is 20. In short, your result here would be 14 minus 50. The determinant of your A sub 1 is equal to negative 36. Now, let's not solve it yet. We are going to proceed with the rest of the values later. So let's continue first with A sub 2. So we will have A sub 2 with the same concern. We will change all the entries of your second column that corresponds to the coefficients of your y to these constants here. So you will have 4, 11, 1, the original first column. Your second column would be 2, 3, 1 instead of 5, 1, 5. You still have 0, 2, and 2. The determinant of a sub 2 is this. 4 times 3 times 2, that's 12 times 2, that's 24. Next, 2 times 2 times 1, that's 4. Then, 0 times 11 times 1, of course, that's 0. Minus the next cycle, you have 0 times 3 times 1, that's 0. Next, 2 times 1 times 4, that's 8 plus 8. Next, 2 times 11 times 2, that's 22 times 2 is 44. So you will have here 28 minus 52. Right? So you will have here a result for the determinant of your a sub 2 is equal to negative 24. Okay? And last, for a sub 3, which corresponds to z, so we change all the coefficients of z with the constants here. So your first column is still 4, 11, and 1. Your second column, 5, 1, 5. Your third column, instead of 0, 2, 2, you will have 2, 3, and 1. So determinant of a sub 3 is equal to 4 times 1 times 1, that's 4. Next, 5 times 3 times 1, that's plus 15. Next, 2 times 5, that's 10, plus 11 is 110. Okay? And then minus all these results. 2 times 1 times 1 is 2. Next, 3 times 5, that's 15, times 4 is 60. And then 5 times 1 is 55, and then you have your 5. So that's plus, sorry, let me use the black ink, plus, 55. So we have here, that's 15 times plus 4 is 19. So you have 129 minus 62, 55, 117. So the determinant of your a sub 3 is equal to positive 12. Now that we have all these results here, let's use these formulas in solving for the values of x, y, and z, and to complete our process. So for x, that's determinant of a sub 1 over determinant of a. Let me use the spaces here. Determinant of a sub 1 is negative 36 over negative 132. You could have negative 12 times 3, negative 12 times 11. Cancel that out. X is 3/11. For your y, that's determinant of a sub 2 over the determinant of a. So you have negative 24 over negative 132. Again, another factor of negative 12 times 2. Negative 12 times 11. So y is 2/11. And for z, this is the determinant of a sub 3 over the determinant of a. So you will have positive 12 over negative 132. So that's 12. 12 times 1 if you would like to. You will have 12 times negative 11. You cancel that out. Z is negative 1 over 11. And these are the results for the variables for this given linear system after using the Cramer's rule. Thank you very much for watching.